This is problem 419. For this, we have these tongs that are gripped the end of a drilling pipe P. If a torque of M sub P equals 800 pound-feet is needed at P to turn the pipe, determine the cable force F that must be applied to the tongs, set theta equal to 30 degrees. So I just did my drawing. I put in the 30 degrees for the theta because that's what was given. And then they want us to find F. So and we know what the moment about P is. So for this one, I'm going to start by just do a quick drawing, and I'm going to make it a little bit simpler than the initial one. So we have point P, then we have this point up here where that force is. And then we know that force is 30 degrees. I'm just going to draw a line here. We know that this distance here is 43 inches. And then this distance here is 6 inches. So I drew this out, and then we also know that moment about P is right here. Moment about P is 800 pound-feet. I think that's everything that was given. So we just sort of simplified it a little bit. One thing that I noticed right away is that we have, this is in feet, and these are in inches. So we'll want those to be in the same, the same units or whatever. So we can just take, it doesn't really matter which one we do. Maybe we'll just change the 800 pound-feet. So we'll do 800 pound-feet times, let's see, in 1 foot, there are 12 inches. So that gives us, and then that would cross out the 2 feet, so that would give us pounds times inches. It's just 800 times 12. So that's 9,600 pound inches. And that should work out. So that's that moment about P. So now we've got that. So we've got consistent units. And then we're just going to sum the moments about P. Let's see, sum the moments about P equals 800. Oh, sorry, not 800. We just did that. Equals 9,600 pounds times inches. And then we'll do coming out of the board as being positive. So if we're doing that, then if you look at the direction of that moment, it's actually in the negative direction. So this will be negative. So the sum of the moments about P. So what we need to do is we need to break down like this force into a X component and a Y component. The reason why we have to do that is because this force isn't perpendicular to that line from P to the base of that force. So I'm just going to break it down into the X and Y components because we know the X distance is 43 inches. And so to get that component of the force, we'll just do 43 inches times that Fy, and then we'll do 6 inches times that Fx to give us that part of the moment. And so an Fx is going to equal F, and then that would be times sine of 30. And then for Fy, it's going to equal F times cosine of 30 degrees. So we basically just have one sort of unknown that I think we're going to come to. So some of the moments about P, we'll start with that 43 inches. We've got 43 inches times that Fy, which is F cosine 30 degrees. And then, let's see, I'm going to move this down just a little bit because I'm going to run out of room. And then we have, and that's in the positive or negative direction. So do the right hand rule. We have to flip my hand over because of the forces, so it's negative. And then for the F sub X, do the same right hand rule. So that's going to also give us negative. And it's going to be 6 inches times that F times sine of 30 degrees. And then that's it. Those are both of the components of the F force, and that's going to equal negative 9,600 pounds times inches. So now we just need to calculate this out. So we have, let's see, I'm just going to go ahead and start calculating. So we have negative 43 times cosine of 30. So that'd be negative 37.24 F, and that's in inches, minus, and then 6 times sine of 30. Sine of 30 is just 0.5, so that's going to give us 3 F. That's also in inches, and that equals negative 9,600 pounds times inches. So this will be negative 40.24 times F, and that's in inches, equals negative 9,600 pound inches. So F is going to equal negative 9,600 pounds times inches divided by negative 40.24 inches. So the inches cancel out. That just leaves pounds, which is good. And that's going to give us, let's see, 9,600 divided by that 40.239. That gives us 238.6 pounds. So I'm just going to highlight that answer. And